In this chapter, we're going to be looking at some classic data structures. And the first of those data structures is the stack. So I've put up the Wikipedia page for the stack just to let you look at a diagram. A stack is an example of what's called a last in, first out data structure. And by that I mean that the last item put onto the stack is the first item taken off. You see an example here in the diagram. We use the method push to put a new item onto the stack. And then when we're ready for the top item to be taken off, we use the pop method. And those are really the two primary methods of the class. There also are sometimes some helper methods, and we'll look at two of those in our example. Peek, which allows us to look at the top of the stack without actually popping the top off, and empty, which lets us know if a stack is empty or has data in it. So with that, we're ready to start looking at how stacks work. So let's get a command prompt window open, and let's start our program. We're going to call it stackexample.java. First thing we need to do is import java util.star. Then we're ready to start our program. We start a stack with the keyword stack, followed by the name of the stack, and then calling the constructor. Notice that unlike our earlier collections, we don't provide a type parameter. All the data stored in a stack is stored as the object data type, which is a bit inefficient, but it's fairly flexible for what we're going to use a stack for. So again, the way we add data to a stack is with the method push. So let's push a couple of names onto the stack. And then let's look at the top of the stack, see what we have. And that's the peek method. And peek returns the top of the stack. So let's compile and run this program to see if everything's working correctly. Notice we get a couple of warnings, but there's no problem. So let's move on and run the program. So the top of the stack is David, which is right. David was the last item added to the stack. So it's at the top, and peek always returns the top. So if we want to remove David from the stack, we'll use pop. And then we can peek at the top of the stack again. Just copy and paste that. So let's compile and then run. So now Raymond's at the top of the stack because we popped David off. Let's push another name on. Then look at the top of the stack. Then let's use empty. So we might say if not names empty, names pop. And then we can look at the top of the stack again. So starting with this line, we added a new name, Cynthia. Then we printed out the top of the stack. Then here we check to see if not names empty. Normally, you'll see the not right by the object name, so we'll take that space out. If it's not empty, we'll pop it because it's an error or an exception is thrown if you try to pop an empty stack. So we almost will always check first. We didn't above just because I knew that the stack was an empty and I wasn't quite ready to introduce the empty method yet. But normally you always want to check before you pop a stack. All right, so let's save that. Let's clear the screen, compile again, and then run. So we started out with Raymond and David. Then we popped David, left with just Raymond. Then we pushed Cynthia. Then we popped Cynthia, and the top of the stack left is Raymond. We can pop one more time. So let's go ahead and do that. And again, I'll leave the empty out. I won't check because I just know it in this case. And then let's see what happens when we try to display the top of the stack. We'll just compile from here and then run. And there's the exception. You can't call peek from an empty stack. So that's why checking lots of times is the best thing to do. So we could add this right here. And then we'll add an else here. a little stack empty message. Let's try it again. Compile, and then run. And notice we don't get an exception this time because we checked first. And so after we pop Raymond, then we try to do a peek. That's in the if statement right here, where we try to peek. And wouldn't let us do it because names was indeed empty. So we went to the else, and it wrote out stack empty. So those are the basics for using a stack. And we'll come back into the exercises in just a little bit, a few lessons from now. And I'll demonstrate one possible use of a stack, and that's to convert decimal numbers to binary.